हाय फ्रेंड्स, गुड मॉर्निंग। टुडे जो टॉपिक्स लिया मैंने बहुत ही इम्पोर्टेंट प्रॉब्लम्स है इंटीग्रल कैलकुलस का। और ये इस बार जो है बहुत ही डिफरेंट टाइप्स का प्रॉब्लम पूछा गया है, तो इसके बारे में हम डिस्कशन करेंगे यार। इस बार डायरेक्टली कोई भी प्रॉब्लम इंटीग्रल रिलेटेड से नहीं पूछा गया, बहुत ही मतलब राउंड राउंड करके प्रॉब्लम्स को थिंकिंग की गई है। So that is a problem. CSI June 17 question number 98 set A and related to the integral calculus. So before watch this my videos, please subscribe my channels, like, share and tell to friends. फ्रेंड्स हम क्या करें, एक लॉजिक, हमारे पास दो लॉजिक्स हैं, आइगन वैल्यू गिवन है, आइगन वैल्यू आर गिवन है। तो एक सिंपल मेथड है कि अगर आप आइगन्स वैल्यू आर डिस्टिंक्ट हैं तो उनके आइगन्स फंक्शन जो होते हैं अगर हम फाइंड आउट करें दैट इज द ऑर्थोगोनल, बट which follow here criteria. So four option we will check, then we get the final answer. So okay, another method, but otherwise we go to the direct. Lambda is given है तो appreciate here first, this is given, put kxt and simplifications find out which is convert to the differential equation form. It means आपको क्या करना है, ये इंटीग्रल पहले एलिमिनेट्स कर देना है और एक डिफरेंशियल इक्वेशन को प्रिपेयर करना है एंड आल्सो प्रिपेयर द बाउंड्री कंडीशंस। तो ये फर्स्ट टू वर्क इज हियर, फर्स्ट क्रिएट मेक द डिफरेंशियल इक्वेशंस एंड find out the boundary conditions. So now come to this given, y of x is given 1 plus lambda 0 to 1 kxt yt dt. So now break it, 1 plus lambda here which is the given, here is given 0 to t and t to 1. तो हम इसको ब्रेक करेंगे, दैट इज हियर 0 टू x फॉर्म में kxt yt dt and plus here x to 1 kxt yt dt. लिमिट चेंज है, सो फिर सिंपल क्या फाइंड आउट कर सकते हैं आप, हियर ktx फाइंड कर लीजिए, दैट यू कैन फाइंड आउट दिस limit of this ktx, simple work. So now y of x equal to, we get 1 plus lambda inside 0 to x kxt yt dt 0 to x फॉर्म में. So x क्या होगा, t से कन्वर्ट होगा और t क्या होगा, x से, that we can find out this. So this is here cos of ht and sin of hx yt dt plus next here x to 1 x to 1. Now this is cos hx, convert to this here, find out, and sin of ht ht yt, this is yt dt. अब next friend, next work, what we do, apply duis and simplifications. Simple, that is you apply duis and convert to differential equations. So now apply duis, dependence on under integral sign, then we get this here y dash is equal to, which is 0, lambda inside 0 to x, partial derivative of this with respect to x, so which is the cos hx convert, means cos of ht cos of hx yt dt plus value of function with upper limit, value of function with upper limit, that is here. तो value of function upper limit means आपको फाइंड करना है kxx. So kxx means here this is, तो cos hx sin of hx into, that is y of x, my here into derivative of x is 1 minus lower limit, that is we get the minus 0, simple. Next come to here same process, then partial derivative of this, so we get here cos means sine, so this is x to 1 sine of hx sine of ht yt dt plus upper limit but derivative करेंगे हम, so we get the 0 minus lower limit function kxx, so here this is cos of hx sine of hx yx lower limit, so that term is same, so which is cancel. Here this is y dash x, so we get y dash x is equal to lambda 0 to x cos of ht cos of hx yt dt and plus x to 1 sine hx sine of ht yt dt. Then we get this y dash x, this is equation number 2. Equation number 2. And फिर go to the next work. Questions 2 here. So now again differentiate, देखते हैं. So now differentiating 1, again differentiate 2. Apply dys on equation 2. So we get here y double dash x is equal to this lambda here. Process again same process, previous process, we get this. So 0 to x partial cos hx means we get the sin hx, cos of ht and sin of hx yt dt. This is क्योंकि hyperbolic function derivative integration are the always positive, and plus function with lower upper limit, so that is here cos h square x and minus lower limit minus derivative of this lower limit, so value of function with lower limit into derivative of lower limit, that we get 0, and here again we get x to 1 sin hx cos hx and sin of ht yt dt minus plus value of function upper limit into derivative of upper limit, so one derivative we get 0, and minus lower limits, so that is lower limit is here, so we get this sin h square x sin h square x. This is, so अब देखिए which is lambda with lambda and we get this here simplifications. तो what we get, मैं erase कर रहा हूँ अभी, आंसर हम फाइनली लास्ट में फाइंड आउट करेंगे. So here this is here and here, so we get what we get, that value here, putting these values, so 1 plus lambda kxt yt dt, so that here means y dash x is equal to here lambda yx minus 1 and that value plus lambda cos h square x minus sin h square x into y of x, so that is 1, and here means y double dash x equal to 1 plus lambda y of x minus 1. Otherwise, y double dash x minus 1 plus lambda yx equal to minus 1. This is equation number 3. Up next, write down the boundary conditions. तो questions prepared हो गया friends. Up next, find boundary condition. So how to find the boundary conditions? तो अभी हमारे पास क्या है, 0 एंड 1 है. तो 0 एंड 1 को क्या करना है, उससे रिलेटेड हेल्प करके हम बाउंड्री कंडीशंस को फाइंड आउट करेंगे. तो फर्स्ट यू फाइंड आउट द बाउंड्री कंडीशन. सपोज दैट इज 0. तो yx इज ऑलरेडी हमारे, वी हैव टू yx is equal to 1 plus lambda 0 to x cos of ht sin of hx yt dt and plus x to 1 cos of hx sin of ht yt dt. That is the value of y of x. So you find out first y of 0 if possible. Check it, y of 0. So we get 0, but here we not get 0. So that boundary condition do not taken. It means अगर आप boundary condition find out करें, put y0 1. So it में आपको constant number find out होने चाहिए, 0 or something. But here we get this. So suppose y dash 0. We get the y dash 0. Y dash 0. How much we get? 0. That term is 0. Or limit is 0. That is total term 0. 0 to 1. Sin of 0. 0. It means that value is 0. This we get the first boundary conditions. Up next, how to get second boundary conditions? Y of 1. Suppose you find out the y of 1. So how much we get y of 1? Here, देखते हैं, 1 plus lambda 0 to 1 cos of ht again same as sin of h1 means. तो हम क्या कर सकते हैं, here write up this sin of h1 sin of h1. ठीक है, sin of h1 no problem. Next 0 to x cos of h t yt dt. ठीक है, that is the value of y1. Next y2, here this is y dash 1 find out कर लीजिए आप, y dash 1 here and h is 1 to 1 होगा, that is 0. But here next तो lambda, here put 0 to 1 again. Here cos of h1 is common, so that is your cos of h1 and 0 to 1, sorry, that is 0 to 1 cos of h t yt dt. ठीक है, this is equation number 4 and 5. 4 5 to solve and find out the boundary conditions. Solve 4 5. Here this is solving 4 5. तो अब कैसे फाइंड आउट करेंगे आप? सिंपल है, आपको इस इंटीग्रल टर्म्स को एलिमिनेट कर देना. तो क्या करेंगे, cos h1 से इधर मल्टीप्लाई कर दीजिए. दिस इज द cos of h1 y1 एंड हियर मल्टीप्लाई करके माइनस sin of h1 y dash 1 and so we get this minus here equal to cos of h1. Otherwise y1 minus tan h1 y dash 1 equal to 1. This is equation number second boundary conditions 4, 5. Suppose that is A and B. Here are two boundary conditions we are get. Next process है find out the solution, means y, what is the value of yx जब when lambda and something, lambda is given. So most important the friends is the boundary conditions को find out करना and then differential equations. So now come here, this simple logic. Lambda is equal to 1. So now from 3, lambda is equal to, sorry, minus 1 given है. So what we get, that is 0, which is 0. Only y double dash equal to minus 1. This is y double dash x equal to minus 1. Y of x is equal to minus x square by 2 plus ax plus b. This is simplifications. Question is given y dash 0 equal to 0. So what we get, y dash x minus 2. So minus x plus a. So y dash 0 equal to 0. Find out this a equal to 0. You find out what a is 0. Find out. It means y of x equal to minus x square upon 2 plus b. अब next target आपका find out the value of b, then we get the first answers. So find out the value of b. How to find this? Use of this and simplify. So y1, second boundary conditions you apply, y1 minus tan of h1 and y dash 1 equal to 1. So apply the second boundary conditions, then we get answer. So we get y of 1 is minus 1 by 2 plus, which is a0 plus b plus, next minus tan h1 here, and y dash 1, y dash minus x, a is 0, so that is here only. What we did, y dash 1, so y dash 1, y dash x, so y dash 1 is minus 1, so which is a minus 1 and equal to minus 1. So which is the transfer, b equal to, so 3 by 2 here minus, no, this is minus 1, so minus 1 by 2, and here this is minus plus again minus tan of h1. That is 1, not minus 1, which is 1. So we get this minus 3 by 2, b 3 by 2 tan h1. So y of x here, put now, find out this, y of x is equal to minus x square by 2 plus 3 by 2 minus tan of h1. That is here y of x is find out the first answer, then the first value. Next, second value for this, the when lambda is equal to 3. So y double dash x minus 1 plus lambda yx is equal to minus 1. That is the solution. Lambda equal to 3. So what we get, y double dash plus 4 y of x equal to minus 1. Simplification. Simplify this, complementary function, auxiliary equations and so on. So simplification, that is finally answer y of x is equal to c1 cos of h2x plus c2 sin h2x and plus here 4 minus 4, 0 minus 4, 1 plus 1 by 4. That is a total solution here. This is solution. अब फाइंड कर लीजिए कॉम्प्लीमेंट्री एंड पार्टिकुलर इंटीग्रल, then we get these answers. So now again apply the boundary condition and check out with this first y dash 0 equal to 0. So first we find out the y dash 0, y dash x, 2c1 sin of h 2x, 2c2 cos of h 2x. Now apply boundary conditions. देखते हैं friends, so apply the boundary conditions first. Y of 0 equal to 0, y dash 0. So apply here y dash 0, which is 0, which is only c2. So simplify, then we get c2 equal to 0. It means c2 0. Now so y dash x is equal to, find out 2c1 sin of h 2x. Apply the second boundary condition, y of n minus tan h1 y dash 1 equal to 1. This is second boundary conditions. So apply this. So y of 1 is here, c1 cos of h 2x. So c1 cos of h2, which is 0, c2 0 plus 1 by 4 minus tan h1 y dash 1 is here, y dash 1 which is 0 only here, 2c1 sin h2, 2c1 sin of h2 equal to 1. तो अब c2 c1 के टर्म को कलेक्ट कर लीजिए, अनदर ट्रांसफर टू दिस, तो c1 cos of h2 minus 2 sin of h2 tan h1 equal to this 1 minus 1 by 4, this is 3 by 4 here. So c1 is equal to 3 upon 4 cos of h2 minus 2 sin of h2 tan of h1. That is the value of c1. So now put the value of c1 is here, give you 7, and we get the final answer. So from 7, so now from 7 is here, y of x equal y of x from 7, then y of x equal c1, this is, so c1 equal to, this means 3 cos h2x, this is divided by 4 cos h2 minus 2 sin of h2 tan of h1 here plus 1 by 4. That is where 1 by 4 with 0. So that is here. So it means 1 by 4 is common. 3 cos of h2x divided by cos of h2 minus 2 sin of h2 tan of h1 plus 1. So this is y of x. So अब देखते हैं आंसर हमारा कौन सा करेक्ट है फ्रेंड्स. According to this is the first and second. So according to this, my second answer is correct. Second is answer is correct. As this second answer is given minus x square upon 2 plus 3 by 2 minus tan h1. ठीक है. And third and 1 by 4 3 cos h2x cos of h2 minus 2 sin h2 and tan h1 plus 1. So according to this is the second answer is correct. बाकी जो remaining answer है that is the wrong. So देखिए कितना मतलब एक lengthy procedure है to find out the that solutions. So take care. Thank you. Bye bye.